Hello everybody doing mechanics, alright? Everybody doing mechanics. Let's talk about projectiles today. Alright, so we're going to draw a diagram like this. And let us say that this is your trajectory, alright? And you're projecting an object at a certain angle, let's say theta. And this is your x, this is your y direction. And let's say the speed is u meters per second. I want to talk about the range today. What is this range? Let's say it's x meters, alright? So how are we going to calculate x meters? Alright. Let's look at the horizontal motion here. I'm going to call it Vx. So we've got something like this. This is theta, and this is u, and we want Vx. The horizontal velocity of the object. That's going to be u cos of theta. There's no acceleration horizontally. No acceleration horizontally. Good. So A is equal to 0. And then vertically I've got something like this. So this is Vy. Look at the vertical velocity of the object. Alright? So over here we've got Vy, which is then u cos of theta. I mean u sine of theta, but it doesn't contain the angle, so that's going to be u sine of theta. And using the equation for motion, I mean for velocity, we know that u is equal to v plus at. Going upward, and therefore we got the force of gravity pulling it down. So acceleration is negative g. So plus becomes minus gt. Okay, so at is gt. Alright, so this is what we've got. Now, at maximum height, we know that the velocity is equal to 0. Therefore, what I'm talking about is that Vy is equal to 0. So we've got 0 is equal to u sine of theta minus gt. In other words, gt is equal to u sine of theta. And what we say is that the time it takes for the object to go from here to its maximum point, the time taken is u sine of theta divided by g. But let's talk about the total time it's going to take for the object to go up and then back on the ground. So that means the other half is going to go back on the ground. It's going to take the same amount of time as it takes to go from here up and then from here down. So twice of that. So the total time taken is going to be 2u sine of theta over g. Having got all these equations, what I can do now, I want to find the range. Okay, let's take a look what we can go. From here, where can we go? Now from here we got the total time, so I want to find the range. So this is the range basically. The range is basically the distance. The distance here is x. What is distance? Distance is speed multiplied by time, which is Vx, the horizontal velocity multiplied by the time taken. So the time taken along this path, alright, and what we're going to do is, therefore, x is going to be equal to the speed, which is u cos of x. So u cos of theta multiplied by the time, t. So that means, let me just put a big capital T over here, just to differentiate between the small one and the big one. In other words, I'm saying u cos of theta multiplied by t, and t is 2u sine of theta over g. In other words, we're saying u times u squared times 2, so u squared 2 sine theta cos theta divided by g. So the range we're looking at is then, using trigonometric double angle formula here, 2 sine theta cos theta, you should be very familiar with this. It's going to be equal to sine of 2 theta, isn't it? So u squared sine of 2 theta divided by g. For any question that is based on projectiles, if ever you've got to find the range, you're going to have to use this formula. You're going to be very lucky if you remember this by heart, but if you don't, there's no need for you to remember. The key is to be able to remember how to derive this formula. So if you're able to derive this in the exams, you should be able to make your way around any questions where you are supposed to find the range. But if you can't remember, tough luck. Otherwise, for the CIE, Cambridge International Examination, advanced level for mechanics, they give you this formula, so you don't have to worry.